Hello and welcome to another tutorial. In this tutorial, I'm going to discuss the differences in operator overloading, which is a language feature in C++ versus Python versus Java. So how can we do operator overloading for different user-defined types like objects, different object types in C++ versus Python versus Java, right? So I have just freshly installed Eclipse, and you see that I'm in the Java perspective. Now what I'm going to do, obviously we want to also do C++ and Python development. So I go to help, Eclipse marketplace, and then the very first thing that I do, I installed CDT, C development environment. So there are other packages on the Eclipse website that you can download and they can come with the CDT installed, but I downloaded the Eclipse for Java developers, which by default comes with JDT or Java Development Tool. But then the Eclipse CDT is available for install. I am going to install it, so confirm, and then it's going to go ahead and download it, and let's finish install. So this allows us to create C++ programs and compile them with the C++ tool chain that is already installed on my computer, which I'm using a Mac OS. So Xcode is already installed. So all the Clang libraries are installed. And as you can see, it's downloading the CDT and installing them. And after that, we have to restart. Whenever we install a new plugin, we have to restart, and then when you install CDT, it basically adds a new perspective. Then you can open a perspective, which is a C++ perspective, and then create all the menus change. So right now the installation is finished. Let's restart, and it's going to reload the Eclipse IDE, and this is the latest version that I'm currently using. So let's wait for it to load. Usually it takes a few seconds depending on the speed of your computer. And sometimes if you haven't set a default workspace, sometimes it also asks for which workspace to open. You can always select the workspace to be the default one, and then it's going to open it by default, right? So right now I just created a folder, test workspace, and that's the default. So I installed CDT, and now you see that this C++ perspective is available for me. So I'm going to select it. All right, and as you can see, all the menus now change. New C++ project. If I go back to Java, the menus are related to Java, which is a very nice feature to have in your development environment. That's why I really like Eclipse idea of being modular and have different perspectives. And obviously what we want to also do a comparison with Python operator overloading. So I'm going to install basically a plugin that allows me to do Python development. I have already installed Python. So it's going to be Pydev. So Pydev is a plugin for Eclipse that creates a Python perspective for you. So I'm going to also install Pydev, and the latest version is 8.3.0. so let's accept the license agreement and finish. And so this is going to download and install Pydev for us, and then again we have to restart each time we install a new plugin. And then it's going to add a Pydev or Python perspective, which we can open up and switch seamlessly between Java perspective, C++ perspective, and Pydev or Python perspective. Obviously, when you open up the Pydev perspective, you have to first configure your Python interpreter path, right? Which Python to use. And if I looked at my command line, which Python, I have already installed Python 3 using Anaconda 3. So Python -- version, it's Python 3.8.5, right? So I have Python installed using Anaconda 3, which is the one I use for my Python package management. And as you can see now, I also have this Pydev perspective. So I can seamlessly jump between Java development, C++ development, and Python development, which is a very nice feature to have. So let's start with C++. So create a new C or C++ project. I'm going to create a C++ and ask Eclipse to manage the build for me, and then a hello world. And as you can see, automatically detected that I have macOS X GCC toolchain. Let's call it operator overloading CPP in C++. So next, and then I'm just going to compile in release mode. This is a very small project, and let's zoom in a little bit. And I'm not sure if we can zoom, but then so right now it's looking for the so it found all the includes, so all the developments, all the header files, and then in the source file we have this operator overloading, and I have this configuration which right now is release, and this is the build. So we can build in the release mode. So if I build this, it's going to compile with the G++, and then the binary is created, and if I run this, it's going to print a hello world. Okay, and let me see if I go back to Java perspective. I think I need to create a Java project. Let's also create a Java project in the Java perspective test, or let's call it operator overloading Java, and I'm going to use Java 15, and or we can just stick with Java 16, which comes by default with this version of Eclipse. That's fine. And next, and then everything looks good. We don't want to create a module info, right? And then let's just quickly create a test or main class. Make sure we can compile, and I think I can increase the font size here, and hopefully that will also change the CSS. So system.out.println hello world. Okay, and we can run these. Yes, and then the CPP, we built this and we could also run it. That's fine. Yes, and now let's also create our Python project. So jumping to Pydev perspective and right click new or file new Pydev project. So let's call this operator overloading Python, and then Python and interpreter. So add project directory to Python path, and then let's config first in path. So let's search path for the let's see if we can find the Python interpreters that I have on my path environment variable, and it found the Python. Let's see, and we're going to grammar version same as interpreter. Everything looks good to me, and then we're going to create the operator overloading Python, and it actually couldn't find so it found the Python in user bean. So I want to change this to Anaconda. So properties, Pydev interpreter, and then open interpreter, okay, page, and then we're going to use a new config from list, choose from list. Let's wait this to process. So we have user bin Python 3, user local bin Python 3. Let's see, let's say new config, no, okay, so not choose from list, new, choose from conda executable, and I am going to users, and then home opt anaconda 3, and let's see if we can All right, so new browse for Python. Okay, so I'm going to give it the path for this Anaconda 3 Python executable, or maybe we go to bin and then give it a path to Python op. There should be a Python executable here somewhere. Let's see. Okay, this one, and it's going to grab all the packages for my Anaconda 3, apply and close. So it's reading the Python path. Let's make sure that everything is set up correctly. It's resolving the modules from the Anaconda 3. And let's wait a little bit. I mean, you just have to do this one time so that Eclipse can find your Python interpreter from whatever package manager you're using. And then after that, you can just use that interpreter for your Python projects, right? And it's very easy to jump from one interpreter to another on your Pydev project. All right, so let's still wait for this a little bit. And I think we just have to wait. Yeah, I guess it's taking some time to resolve the packages or modules. Let's try to cancel this and see what happens. So I'm going to pause the video and then come back when this is done. Alright, now our Pydev project is also set up. So we set up 3 different projects. One is a C++ project, one is a Java project, and one is Pydev project. And our Pydev project is set up based on Anaconda 3, right? And we have all the Python 3.8 packages from Anaconda 3. Alright, so let's start with C++. So I'm going to switch to C++ perspective, and then what I'm going to do here is let's remove this. I'm going to what I'm going to do, I'm going to create a class. So class let's call this point. All right, and then this point is going to have a private section which has a double X and Y, and then it has a public section which we have a constructor point, and then a double X double Y, and then we're just going to initialize them with basically initialize the components. And then we don't really need a destructor because we're not managing any memory or pointers, we're not managing any resources. So I can allocate a point on the stack. So point P, and then initializer list 1.1 2.2, right? And then I can say stdc out p.x, and then a space or comma, and then p.y. All right, so let's look at this and let's build. And then so we have an error, private field y is not used. That's fine. And then so let's see at the end of declaration here what is going on here. 1.1 2.2. Let's build again. Okay, X and Y are private members. Obviously we can, for now let's just declare them as public and build again. and it seems to work just fine, and we can run these. All right, 1.1, 2.2, right? And let's create another point. So point P, let's call this P1 and P2. P1 and P2 -5 and -5, right? And then let's say we want to add these together in a nice way. So point P3 is P1 plus P2. And obviously if I build this, it's going to give me an error on this line, because right now the compiler doesn't understand invalid operands to binary expression point and point, because it doesn't understand how to interpret this. And we can define a global function to overload plus for point class. All right, so this is going to return a point, and then we're going to say that operator plus. So it's, you can also add the plus to the class, but usually for the binary operators it's better to overload them as a global function, right? So the way we do it in C++, you use the syntax operator keyword plus, so operator, and the operator that you want to use right now plus. So this operator tells the compiler whatever comes after the operator is the symbol for the operator they are going to call, right? And then point P1 and then point P2, and then we're going to basically say that return point. Now obviously if we we're just going to directly create a point here, p1.x plus p2.x, p1.y plus p2.y, and we're creating on the stack. That's fine because we return this, and then the return is going to be copied in point 3. So if we build this, hopefully this works. Yes, and then now the compiler is not complaining, it's just giving us a warning that you never use this p3. So let's just use p3 to confirm that the compiler is actually replacing this symbol with the call to this function. All right, let's run this. And yeah, so let's add the \n here. Let's save this and run this again. And as you can see now, the compiler, now P3 is calculated, -5 plus 1.1, which is -3.9, -5 plus 2.2 is -2.8. Now we successfully overloaded the operator, right? So we create a point on the stack, we return it, the return value, the temporary which is on the stack is destroyed when we return, but then we are also returning by value. So a return, so the temporary is copied here by value and then it's destroyed. That's fine. We still have a hold to this object, the temporary, and it gets passed to P3, right? And then now as you can see, we were successfully able to overload the operator. We could also overload this inside the class. We don't need to have a global function. We could just say operator. Obviously it has to be public, right? And then it's going to return a point by value, operator plus, and then we just pass it a point p or other, right? And return point x plus p dot x and y plus p dot y. We could use this arrow x, or just tell it x. It already knows that what's going on. So hopefully this also works fine. So in C++, you can overload a binary operator either inside the class or as a global function. It's more common to overload binary operators as a global function. And the reason here is that what happens if we want to basically have, so right now it's p1 plus p2. Let's say what we want to add a basically when you do it inside the class, it's always this plus whatever comes after that, right? So you don't have an option, so no option for whatever is passed plus this object, right? So if this object is not of type point, this p, then we have a problem, right? Because this operator plus the first argument inside the class method is always this implicitly, but in a global context, the first argument doesn't have to be a pointer. It could be a double, and then the compiler knows how to bind that double plus a point and then how to calculate it. Inside the class, we don't have the option, right? This one is operator plus. Always assume that it should be applied to this class, this point type, right? So we don't get a chance for the other type that is pass plus this. So this is how we overload the operator in C++. And it's always the keyword operator plus whatever the symbol is. What about the Python? So let's create a new package, test. And then I'm going to create a Python module, test. Let's go test 1. And then what I'm going to do, I'm going to create a class point, right? And I'm not going to inherit from anything. We could inherit from object, but that's fine. And then let's add the initializer x and y, and then self.x equals x and self.y equals y. And then how do we overload the operator? So we use a double under, so double under methods, or the magic method. So we overload basically the add method, right, which takes another p or point, and Python is dynamically typed, so it doesn't matter what this is. We have to use reflection, for example, is instance, to inspect the type of this. But right now, let's assume that this is just a point, so we return another point, self.x. Note that we have to use self because passing the pointer to the object is explicit in Python, which is a little bit odd, but that's how it works. Self.y plus p.y. So that's how we do it in Python. We overload these magic operators, or provide implementation for magic operators. So, and then we can go if name equals main. If this module is run, what happens? Or if this module is run as the main module, we're going to create p1 point 1.1 2.2, and then p2 is point -5 and -5, and then we're going to p3 is p1 plus p2, and then print %s comma %s, and then %p3.x p3.y. All right, let's see how this works. Let's run this Python, and as you can see, we're getting -3.9 and -2.8, which is the same result as here, right? -3.9, -2.8, -3.9, -2.8. So that's how we overload the operators in Python, right? We add implementation, and if you want, so this one add is this plus the other. If we want to have other plus this, we have to use the reverse operation, def __ r add, reverse add, right? P reverse add calls the add on this p, right? And then because addition, in addition order doesn't matter, we can basically do the same add. Or let's assume that p here now in reverse is a double, right? So, and then we can say just add p to x and y. So basically this means, let's say if we say p plus this, and then p is going to be double. So if I say p1 plus 2, this is going to fail. Yes, because it's going to call the __ add on this object and pass this, but this is a double or integer, it's not a point. However, if we reverse the p1, right, It realizes that an integer doesn't have radd, so it tries to run the or call the radd on this object, and then this works. So let's see. Yes. So reverse addition is called when the first argument in a binary operator doesn't have the add method, so Python cannot add it. And again, same here. If we implement as a global operator in C++, then we have the freedom to set the type of the first argument as point, double, integer, whatever, right? So it's much more flexible because we can overload that global function. In a class, when you add this binary operator as a class member, the assumption here is that the first argument is always this, right? So so you cannot have the other argument plus this. You cannot implement this. So you have to implement it as a global function. That's why it's always recommended in C++ to overload binary operators as global functions so that you can pass different types. So what about Java? And so the sad irony is that Java by default doesn't support operator overloading. So what we need to do, let's go to our Java project. So what we need to do, we have to ask our IDE to do the heavy lifting, and we are going to, if you're using Eclipse, it's very easy. You have to install a plugin that allows operator overloading, and what it does, when it sees, because Eclipse doesn't use a Java C compiler, right? It uses its own compiler, and we can add a plugin to Eclipse that patches that compiler so that whenever it sees a plus sign between two Java types, it calls a, for example, add method in a Java class, right? So let's create our class point in Java, and then so we're going to have double x and y, and point or public point double x double y, and then this dot x is x, this dot y is y, right? And we can also override the toString method. So source override toString. Let's accept the default. And then in the main, we're going to create a point. P1 new point 1.1, 2.2, and then point P2 new point -5 and -5. And then point P3 is P1 plus P2, sysout P3, right? And I can also sysout P1. And obviously right now Java compiler, the Eclipse compiler, is complaining. It's saying that the operator plus is undefined for the arguments point and point, right? So right now we cannot do any operator overloading. So, but if I run, let's say P1, and let's print it to the console. Yeah. So even if I go inside here and say public point, add a public method which has the signature of add, another point P, and return new point x plus P dot x, y plus P dot y, right? So even if I do this and go back to my Java and uncomment this, this is a still complaint. So this is adding this add method is very similar to what we did in Python, right? But then Java compiler doesn't know that when it sees two types of type point and a plus sign, which is a binary operator, it has to bind it to this add method, right? That's what we want, and in order for this to happen, we have to kind of tell the Eclipse compiler how to interpret this. So what I'm going to do, I'm going to go to Eclipse Marketplace and install a plugin. Actually, we need to install two plugins. One is AspectJ development tool that allows us to patch the Java C compiler. So I'm going to install this. Let's accept, finish. So it's going to install. It's a quick installation, and after that we're going to go to GitHub and search for, so go to Google and search for GitHub Java -operator overloading. The second one, Melentev Java 00, and it has a Eclipse plugin, right? And then if we go here, it has a Eclipse update site. So this one is still it's done compile installing. And now let's copy this address for the Eclipse update site for this plugin, Eclipse basically Java operator overloading. And then we're going to install this Eclipse plugin. And then what it does, it tells the Eclipse Java compiler to bind the binary operators like plus. When it sees 2 point types, it binds that operation to the add method inside the point class. And that's how we can overload the operators. And that's a very elegant solution. And that's something that Java should have provided, but it didn't. But then other languages like Python, C++ provide this operator overloading. Now the good news is that all the IDEs come with their own compiler, right? So that we can easily overload the operators. All right, so so back to our Java perspective. Let's see. I am going to go to the install new software and then add a Java OO, and the address is the one we copied from the GitHub. And you see it says Java operator overloading for Eclipse. So this uses the AspectJ compiler to patch through the Eclipse compiler, Java compiler. So let's quickly install this. All right. So this is also installing. It's going to be relatively quick. And then we have to restart one more time so that the Eclipse loads the plugin. And after that, hopefully this line of code will work, and the Eclipse compiler has no problem to bind this plus call to the add method inside the point class. And this is a very nice feature to have inside Eclipse IDE, and this guy has developed plugins for other IDEs like IntelliJ or NetBeans. So if the Java or JDK doesn't provide operator overloading, we can ask our IDE to replace the plus operator to the call to methods inside the classes that we're using. And that's the meaning of operator overloading in an object-oriented language like Java. So let's wait for the Eclipse to load one more time. And hopefully we see the effect of this operator overloading plugin. And we can also examine the bytecode that the plus operator is actually replaced by a call to the add method inside the point class. All right, so operator overloading in Java, and then let's confirm that our plugin has been installed. So let's check the installed plugins. So operator, Java operator overloading, so it's installed and it's in use. So what happens if I comment this line? So AspectJ is it's complaining, but as you can see, this is not returning any errors. So hopefully this line of code works. So let's see. Yes, and as you can see, this this line is now easily compiled by the Eclipse compiler. And if I go to the point class and comment this add method, and this is going to complain now because it says it doesn't know what this operator plus means for 2 types point. If I go and uncomment this, Eclipse automatically compiles this, and now we can actually look at the bytecode of this main class. So if I go to Window, Show View, and then let's look at the navigator, and then operator overloading Java, Bing, and then let's just let's try to open this up. So we have this main class. If I drop it here and look at the bytecode, we have this invoke virtual. So we load a point 1 reference, point 2 reference, invoke virtual. Invoke virtual means call a method, a non-static method, What is that method? From point class called the add method, and the argument is the point, right? So when we have P1 plus P2, it calls the add method on the P1 and passes P2. So add method in the point class takes a point and returns another point, right? So you see now the Java compiler using this plugin inside Eclipse, it binds this plus sign to the right call in the method, which is the meaning of operator overloading. What if we replace the second one with a double? Now, because Java allows method overloading, we can go ahead and replace this point with the double, right? And now you see this one is not complaining, and if we run this, it's going to add 2. So 1.1 plus 2 is 3.1, 2.2 plus 2 is 4.2. So again, the Java compiler knows how to correctly bind this to the method. What about if instead of saying 2 plus point, we want to say 2, instead of saying point plus 2, we want to say 2 plus point? What about this? Right now, this is a reverse operation, and obviously 2 is not a point, so it doesn't have a add method. So just like in Python where we call the reverse add, with this plugin we're going to say add rev, add reverse. So now and then we're going to do the same thing for a double value, add reverse double, and then x plus p, y plus p. As soon as we add this, Eclipse compiles this and has no problem running this. Yeah. So in Java, it's very easy to ask our IDE and install a plugin for it, and it completely allows operator overloading. And the beauty is that Java already supports method overloading. So if we want to add a double to our class, or another point, or any other type of object, any object that is not related, let's say we wanted to add public add, we wanted to basically let's say we want to add a string to our point. So a string add, so we create an add method which takes a string and returns a string, right? And let's say we return point equals like %s, %s, and then let's say we just put the string as the name str, so %s. Let's call this formatted str x and y, something like this. So if we add a string, it's going to return a string. So sysout p3 plus name, and as you can see, this compiles fine, there is no problem. And oh, okay, so this calls the toString method on this. So I guess this is not a good example. So if we add a string to this and it returns a string, so the way Java sets the priority is that if we add a point to a string, so if we say a string p4 is p3 plus name, Java is going to call the toString method on this, and in some way this plus is already overloaded for objects and string types, because any object can be converted to a string. So this is going to call, this is equivalent to p3.toString plus name, and the plus sign is already overloaded for the strings. So Java knows how to, what it means, which means just concatenate them. So maybe this example wasn't that great. What about char? Let's say we add a, so this works. So a string p5 is p3 plus n. Let's see what p5 returns. And now it doesn't, it calls this method, add method, right? So basically this doesn't call the toString and doesn't add the end to it. I mean, it doesn't do this, right? Because this plus is not overloaded for strings. So this calls this This does the string concatenation, but if we don't do this in Java, it's going to bind this operator plus to this method that we already defined, right? Again, operator overloading in action. So I hope you enjoyed this lecture and now have a very solid understanding of operator overloading in Java. Please stay tuned and I'll see you in the next one.